What is titanium foam? For centuries, humans have engineered structures based on the sole idea that each must be stronger than the last. By following such an idealization, structures utilize durable, more dense materials to construct the modern artifacts and commodities that we see today. However, this makes objects rather heavy and immobile, which makes it useless in emergency situations. A multitude of contemporary metallics are characterized in such a manner, especially those that are larger. Yet, what if there was a possibility that objects with the same strength of metals could also weigh the same as a small mouse? This is where metal foams, specifically titanium foams, have come into the limelight. These foams are porous metal structures which aim to be incredibly lighter and stronger than typical solid structures. This video will cover in detail the chemical specifications and influence that titanium foam has had on the world of engineering and chemistry. First, however, it is important to address the prime uses or future uses of titanium foam to better understand the dilemmas it has resolved or will resolve. Due to its versatility, titanium foam has the potential to be deployed in a variety of industrial sectors. To avoid taking too much time, I will go over the top 2 industries that titanium foam has enhanced. Number 1, the business of aerospace, and number 2, the field of biomedicine. One of the most revolutionary applications of titanium foam lies outside our planet, in what is known as sandwich panel cores. Sandwich panel cores are simple structures created by attaching 2 thin but stiff skins to a lightweight thick core, ultimately fabricating a very strong and protective layer currently integrated into aircraft bodies, floors, and internal panels. Aluminum is the present source for sandwich panels, but aerospace engineers hope to replace aluminum with titanium foam. Titanium foam's strength to weight ratio offers an opportunity to provide increased bending and shearing stiffness, as well as energy absorption during periods of bending. And not to mention, titanium foam can also be utilized in elevated temperatures nearing 1600 degrees Celsius, whereas aluminum can only handle around 660 degrees Celsius. Since space requires objects that can handle extreme temperatures, it makes sense to use titanium foam over other elements such as aluminum. Since titanium foam offers so much more, why not substitute it in? The second industry that titanium foam assists is the field of biomedicine. Once again, the properties of titanium, such as its strength to weight ratio, identifies it as a key candidate for bone replacement. Peter Kwadek, a researcher for Fraunhofer Institute for Mechanical Technology and Advanced Materials Research in Dresden, Germany, uncovered that an implant may end up carrying a far higher load than the bone it is placed next to, strengthening other local bones in that surrounding area. The titanium foam does a better job than solid metal when it comes to matching the mechanical properties of bone, such as flexibility, and this encourages effective bone growth. The best part is, the foam is porous, so the bone can grow around and within it, truly integrating the implant within the human skeleton. This makes titanium foam a true merger of biology with modern technology. As effective and useful as titanium foam currently is, and perhaps will be in the near future, its effect on natural resources will, nonetheless, become a major point of interest. Looking into the finer aspects of the foam's creation, it would be absurd for one to think that titanium is harmless to the blue ball of water and solid that we call Earth. Titanium is itself a metal, and therefore must be mined, as most metals are found scattered in varying distances deep within the Earth's crust. For mining to take place, machines that require non-renewable fuels, such as oil, must be utilized. Those machines then emit carbon dioxide pollutants into the air as a result of burning the fuels. The flip side is that titanium is a corrosion-resistant material that has a lifespan which is virtually limitless and therefore a great resource for recycling. Titanium is also the 9th most common element in the Earth's crust, making it reusable, yet not permanent. Nonetheless, there is an abundance of titanium in the Earth for future generations to experiment with. The biocompatibility and low toxicity levels of titanium also renders it nearly harmless to humans or the environment, considering it as an element found in nature. Titanium foam itself provokes no danger to the Earth as a product. However, the retrieval of the main ingredient for the product, titanium, is a process which dangerously harms the planet through carbon dioxide emission. So, to effectively mine this product and create it, we must find a more environmental friendly solution to mine titanium from the Earth. For the future, there is one large project in the arms industry that shows great promise for becoming a reality. The military and police force are always looking for updated and more protective gear when they go off to fight in battles. Bullets are often the fear for many fighting individuals due to their sheer speed and ability to pierce nearly any form of defensive mechanism. An inch of titanium, however, is found to have not only stopped but shattered the bullet, as according to a professor at the North Carolina State University. The university has not yet stated the exact type of titanium foam metals used in their alloy armor, but it was stated by Fox News that in fact a composite form of titanium foam was being stitched into the design process. This development would allow soldiers to become increasingly more mobile with higher protection, nearly immune to modern bullet fire, leaving soldiers less vulnerable on the battlefield. All in all, there are a large number of problems that require fixing in our world. The invention and implementation of titanium foam is most definitely a step in the right direction for humanity, as it not only offers the potential to keep us safe from each other, it can be also implemented into space shuttle design to protect us from what lies in the vast pocket of darkness that is space. Titanium foam offers so much more and can manifest a future that has the likelihood to be great.